In Antarctica, where a corner of the giant Ross ice shelf is melting 10 times faster than the rest of the shelf. The National Institute of Water and Atmospheric Research discovered it was happening as part of a collaborative research project which has just been published in the prestigious journal Nature Geoscience. NIWA's principal marine physicist Mike Williams and others studied the northwestern corner of the ice shelf for several years to record how it was melting and what was causing the melt. And Mike Williams joins me in the studio now. Just how significant is this ice melt, Mike?
We think it's quite significant because one of the things we've been trying to understand about the Ross Ice Shelf is how vulnerable it is to warming. We know other ice shelves around Antarctica are experiencing warm ocean waters coming in and melting the ice shelves faster than expected, but we've thought the Ross Ice Shelf was relatively protected. And this research has highlighted a new mechanism that creates some vulnerabilities for the Ross Ice Shelf.
So what is the principal cause for the melt?
So the principal cause for the melt is summer warming. So in summer we have the sea ice breaks up and we have open water, and as Antarctica comes out of its long night, the summer sun warms the water, and that water moves underneath the front of the Ross Ice Shelf and drives melt under the ice shelf. So
what are the consequences of that?
Well, the consequences really come from where that melt is, and that melt is right up against Ross Island, near where New Zealand's Scott Base is, and the Ross Ice Shelf is pinned against that island, and our concern is that if those melt rates accelerate, that pinning will disappear, and that could lead to a very rapid retreat of the Ross Ice Shelf.
So is this man-made? I mean, to what extent? You talk about sunshine actually being the principal cause, but what's the human contribution to that?
So the human contribution really comes from the wider scale climate changes in Antarctica, with the sea ice potentially opening earlier and letting more light in. But really, it's probably a process that is part of natural variability. But the key thing for us is that we have not been including this process in our forward projections of what will happen to Antarctica. And so what we might find is by the time we add this process in as well, our projections of when Antarctica may melt and its contribution to sea level rise might move those timeframes forward.
You talk about probabilities and variability. Is there a possibility that, in fact, nature will take a course and that melt rate will slow?
I think that's unlikely, because fundamentally we're looking at a process where as soon as Antarctica comes out of its night, the sun starts shining. That's one thing we can't change. The Earth will still keep going round and we will keep having seasons. So it's very difficult for us to come in and change that process.
The result, of course, is rising sea levels.
Yeah, the result is rising sea levels. And what we're starting to understand is the vulnerability that New Zealand has and the globe has to rising sea levels. And the challenges that we see of being able to prepare for those rising sea levels.
Any signs that this is happening anywhere else in Antarctica?
Well, the other place where this could become a risk in the large ice shelf, the Filchner-Ronne ice shelf, which is in sort of south of the South Atlantic and also one south of Australia. What we tend to be seeing is the smaller ice shelves are responding to warm water coming up from the deep ocean and going underneath the ice shelves. And that is a process that is linked to climate change. So ice shelves really are a little bit of a canary in the coal mine for us around what's happening in Antarctica.
And what's your next steps in research?
So we're already undertaking some of the next steps. So NIWA has new measurements taking place further back from the ice shelf, in the middle of the ice shelf, so we can see how far into the ice shelf this goes. And working with other New Zealand research colleagues, there'll be a project this year that goes to the far back of the ice shelf to see what's going there. And otherwise, the next step is to get our research into the forward climate models and start doing some work for us to understand how things may change in the future and really to get a handle on the role of oceans and ice shelf melting.
Somebody very quickly just texted in saying, does this have anything to do with the decline in the penguin populations?
I don't think it's linked to the decline in the penguin populations. That's more related to the sea ice and changes further away from the continent.
Thank you for your time this morning. That's NIWA's principal marine physicist, Mike Williams. We've taken a bit of time, 24 minutes to 9. Just give you a quick update on financial